This video is on Lewis dot diagrams in ions. So to make a Lewis dot diagram, we need to be able to count our valence electrons for an element. The valence electrons are the electrons in the outermost energy level. These are the electrons that are transferred or shared in a compound. So we can find out our valence electrons by looking at the periodic table. My valence electrons are equal to the group number that the element is in if we exclude our transition metals. So going across, our valence electrons for group 1 has 1 valence electron. Group 2 has 2. We skip our transition metals. Group 3 then has 3, 4, 5, 6, 7, and 8. Okay. Remember, we have our dividing staircase line between our metals and our nonmetals. And anything to the right of that line are considered nonmetals, and anything to the left of that line are considered metals. To show the number of valence electrons around an element, we can draw something called a Lewis dot diagram. Lewis dot diagrams are going to show the valence electrons as dots around the element symbol. So if we find lithium, lithium is in group 1. Okay, so because it's in group 1, 1 valence electron, so we draw 1 dot above lithium. Beryllium is in group 2. And so it has 2 valence electrons. Now we want to put each one by itself first before we pair them up. So beryllium has 2. Boron is in group 3. It has 3 valence electrons, 1, 2, 3. Carbon is in group 4, so it has 4. 1, 2, 3, 4. 1 on either side of it, top and bottom. Nitrogen in group 5 has 5 valence electrons, so we put our 4 around, 1, 2, 3, 4, all by themselves, and then we can start pairing them up. Oxygen in group 6 has 1, 2, 3, 4, 5, 6. And then fluorine in group 7 has 1, 2, has 1, 2, 3, 4, 5, 6, 7. And neon, which is in group 8, has 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. Remember we talked about our group 8 elements as the noble gases, and they had that full outer shell. So notice here, neon has that full outer shell. All of the spots that can hold an electron have an electron in it. So we also talked about that electrons want to become like our noble gases. And to do that, they either are going to add or lose electrons. Now metals, they are going to lose electrons. They're going to become positively charged, and they are called cations. Metals are going to gain electrons. They're going to become negatively charged because they're gaining negative electrons, and they are called anions. And we can show this transfer or loss or gain of electrons using our Lewis dot diagrams. When we lose or gain electrons, we end up with a charge on our atom to make an ion. So the charge, should say charge, for group 1 they're going to lose their valence electrons, so they're going to have a charge of +1. Group 2 is +2. Group 3 is +3. Group 4 is going to be negative or positive 4, depending upon if it's a non-metal. So these guys are going to be -4, or metal are going to be +4. Group 5, mainly non-metals, so they're -3. They're going to gain 3 electrons to get to 8. Group 6 is going to be -2. group 1 minus 1, and our noble gases are not going to gain or lose electrons, so they're going to stay as 0. So this leads to ions. Ions occur from a loss or gaining of an electrons. If I have a metal, my metal, like I said, is going to lose its valence electrons. It's going to become positively charged. And is considered a cation. Nonmetals are going to gain electrons to have 8. And they're going to be negatively charged, and they're called anions. When we say that a nonmetal wants to have 8 electrons, that's called an octet. So that means that all those electrons are present, they're all paired, and it has a full outer shell. Now if we want to name these, a metal, the name of a metal ion is just going to be the same name of the metal, and then we add ion for the second word. For nonmetals, their name is the stem of their element name, and then we drop the INE ending and change it to IDE. So for example, I have calcium. Calcium as an element has 2 valence electrons, here and here. It's going to lose those 2 valence electrons because it's a metal, and it's going to just be calcium with no valence electrons around it, so we say calcium plus 2. To name that, our metal name is calcium, and then we just write ion after it. So for aluminum, it's in group 3, so it has 3 valence electrons. It's going to lose those valence electrons to have none in the outer shell here, and that's why we add this plus 3 to show that I lost each one of these electrons. So to name that, I just have an aluminum ion. Now for nonmetals, sulfur has 6 valence electrons, 1, 2, 3, 4, 5, 6. It has 2 holes. It has a hole here and here. So it wants to gain 2 electrons to have a full octet. So it ends up with sulfur with 8 total electrons. And that means it has an overall charge of -2. So when I name that, I have sulfur. So I have sulf is my stem, and then I have IDE. So I have a sulfide ion. So for fluorine, as an element, or an atom, it has 7 valence electrons. It has a hole here, because it wants to have 8. So when it gets 8, it ends up with 1 more electron than what was given to it originally. So that's why we have this charge of -1. So to name that, I have fluored, F-L-U-O-R, and instead of I-N-E, I have I-D-E, ion. Ionic interactions happen because of electrostatic forces. An electrostatic force is what holds 2 ions together because of an attraction of positive and negative charges. The positive charge coming from the cation and the negative charge coming from the anion. This occurs from the transfer of an electrons in an ionic compound. So we're going to show that. I have aluminum, Al, and I have fluorine. Aluminum is in group 3. It has 3 valence electrons. 1, 2, 3. Fluorine is in group 7, so it has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. Notice that fluorine has a hole here, and aluminum has 3 electrons. Aluminum is a metal, so it wants to lose its electrons. So it is going to donate its electron here to the hole in fluorine. Aluminum still has 2 more electrons to give, so that means 2 more fluorines need to come about to accept the 2 more electrons from aluminum. So one would donate an electron here, and one would donate an electron here. So that means each one of my elements, or my atoms here, have now turned into ions because they've either gained or lost electrons. So I now have an aluminum with an overall charge of +3 because it lost 3 electrons, and I have 3 fluorines. Each fluorine has gained an electron, so it has a charge of -1 for each one. Notice that my 3 fluorines have an overall charge of -3, and my 1 aluminum has a charge of +3, so my compound that I make has an overall charge of 0. I have 1 aluminum, and I have 3 fluorines, so I use a subscript down at the bottom to show how many fluorines I have. I could have a 1 after my aluminum, but in chemistry we don't write 1s, so we just take it away, and we just have AlF3. This is also known as aluminum because that's my cation's name is aluminum, and my anion's name is my fluoride.